Hi, everyone. So, as Silas has mentioned, over the past winter season, I've been working on energy data visualization. And specifically, I've been working with the staff members down at the biomass to collect data about Hotchkiss's electricity consumption. So Mr. Han was gracious enough to provide us with a spreadsheet. As you can see on the right, we can see all the electricity usage and cost for each month for every building on campus. On the left is a code that I've written on Processing, which is a platform based on Java. Now, if we run this program, you can see a short animation of how the energy is distributed around our campus. The radius signifies the amount of electricity used per building. And so if we click on this screen, we can see how this energy consumption changes over a couple months. And we can see how the MAC or these big buildings like the main building are actually consuming much more energy than our dorms or our faculty housing. In addition to this map, I've also written an HTML code which is supposed to receive data and output it into a stream graph. If we run this HTML file, we will see this line graph, and if you click the update button, we can see how the data changes over the course of a couple of times. This graph is actually having sample data at the moment, but we can always replace this data with the data from the biomass or the electricity usage that we have in our campus. So now, but this data visualization is not only focused on graphs and maps, but we can also visualize these data points in a very artistic manner. So Mr. Locke will briefly introduce us about that.
Nice job, I'm actually going to leave the introduction to someone who's had a big hand in the project. Light painting and long exposure photography is a long-standing art form, and we've been experimenting with that using some nifty technology. And here to introduce it is Nico Zingarelli.
Hey everyone. So last week, our Advanced Digital Studio class went out after check-in down to the biomass facility, and we took with us a pixel stick, which allows us to visualize movement. So as you can see, pictures like this one here were actually filmed by Jackie and Mr. Locke flying drones with lights attached to them, which you'll get to see later. But in this project, you can see, instead of visualizing the energy uses here, you can see movement. So our class has been focusing a lot on visualizing different types of data. And do you want to talk about one of the drone ones?
So we've attached an Arduino computer onto these drones so that they're programmed to produce a rainbow, array of rainbow on an array of LED lights. So if you zoom in a little bit on one of these pictures, you can see how individual pixels are changing their color over the course of a couple seconds. We've captured this image through a long exposure shoot, and so this is one of the images that we've been able to capture.
So could we have the house lights off, and then the other lights, I think it's 20% we decided?
So we will have a quick demonstration of how this works and on stage.
Yeah.
Remember what you did. Okay, bring it back, bring it back, bring it back. It's beautiful. Bring it back. Okay. Bring it back, bring it back. Straight back, straight back. Now down, back, down. Back.
In trouble.
Back.
Give me some time.
Down. 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 Backwards. Backwards. Straight back now. Green light is backwards. Straight back. Straight back. Now down. Get it, Nico? Down. Let's go. Okay. Actually, could we keep the lights down to the same levels? As you can see, this is the light painting that Jackie just made. He's having a little trouble getting it back on stage, which. And then the other piece of documentation that you may have seen our fabulous maestro on the pixel stick operator, Will York. He is about to give us one final demonstration, which is our send-off. And we'd like to thank you for your attention. Will York. 3, 2, 1, go.